Hello, welcome to today's lesson on section 12.2. This section is titled Arithmetic Sequences and Series. So I think the first order of business would be we got to talk about what is a sequence. A sequence is simply a set of consecutive integers or actually consecutive numbers. Let me rephrase that. Say consecutive numbers that follow a certain pattern. So that's what's considered to be a sequence. A series is simply the sum of a certain number of terms in a sequence. So for example, if I like 1, 4, 7, 10, 13, call dot dot dot, that right there will be a sequence. But then if I had this, 1 plus 4 plus 7 plus 10 plus 13, that's a series because I'm adding up a certain number of terms in the sequence. Now what makes either of these arithmetic? That's if a common difference exists between consecutive terms. Looks like I forgot how to spell consecutive terms. So if we think about it, 1, 4, 7, 10, 13, hopefully you see the pattern. Every term differs, or consecutive terms differ by 3. So it seems like we're adding 3 every single time. So both of these here, 1, 4, 7, 10, 13, and 1, 4, 7, 10, 13, all added, are both arithmetic. But what if, you had an arithmetic series that lasted for 20 terms, or I wanted to find like the 40th term of the arithmetic sequence of 1, 4, 7, 10, 13. So that might be hard to count or list them all. If you want to find some of the first 20 terms or the 40th term. So here's the question: are the formulas associated with arithmetic sequences and series? And the answer is a resounding yes. Here are the formulas. So the rule for an arithmetic sequence is the following. So A1 is always the first term. AN will be the nth term, meaning whatever term you're looking for. If you're looking for the 5th term, n would be 5, or the 6th term, n would be 6. N will be the number of the term. So again, if you're looking for the 6th term, you plug in 6 for n. And D will be the common difference. For a series, sum of a series equals to this. Where S represents a sum. A19 equals 48, and we can solve for A1. So if I let n equal 19, again, we know the common difference is 3, where A19 is 48. So if you work it out, you should get 54. So A1 will equal negative 6. So your rule would be AN negative 6 plus n minus 1 times 3. So very, very simple. And then this one here. Two terms of arithmetic sequence are A8 equals 21, A27 equals 97. Find a rule for the n term. So again, we have this formula. The problem is we don't know AN. Actually, we don't know A1. Nor do we know what D is. So a couple things you could do. You could try making two equations. So A8, A1 plus 8 minus 1 times D. We know A8 is 21, so 21 equals A1 plus 7D. Also, A27 equals A1 plus 27 minus 1 times D. A27 is 97, so 97 equals A1 plus 26 D. We can solve for D. There's a bit of algebra here to do some substitution. Move things around, you get 76 equals 19D, so D equals 4. And if D equals 4, A1 would be 21 minus 7 times 4. A1 will equal negative 7, I believe. Yep. So my rule, AN equals negative 7 plus n minus 1 times 4. Yep, that looks right to me. Another way you could have done it too, you could have said A27 minus A8 divided by 19 equals D. That's because there's 19 terms along the way from A8 to A27. That could have worked as well to find what D equals, because then you would have 97